Relax.
Yep.
Welcome to session 4 of BPS Summer Coding Sampler. Hi, I'm Rashmi.
I'm Haruna.
Let me quickly move to the slides. This is just... Thank you. Okay. So welcome again to the session 4 of BPS Summer Coding Sampler. Today we are looking at the introduction to AP Computer Science courses. Moving on, just in terms of the logistics of this course, we'll look at the BPS Learns, which has the link to this webinar. So let me quickly go to the course. This is our summer coding sampler. You have the course syllabus, and right in here is the introduction to AP Computer Science courses session. The webinar link will be posted here. Today's Meet link is right here. If you are joining us live, please join us using this Today's Meet link. The exit ticket is posted, the readings and journal entries. This is a homework assignment, so please click on this link to go to that homework assignment. And then there is an implementation of an algorithm using Scratch example, which we'll talk about in a little while. Coming back to the presentations. Just in terms of quoting the sources, I've used a lot of media assets and examples from this following courses, which is code.org, CS Unplugged, ECS site, the AP College Board website. Also, we have an example from Bethel High School. So just making sure that you quote sources as you use materials is very important. So we are also trying to model that in our webinars. Moving on, today's session and agenda will focus on, striving for equity with access to CS for all education. That's sort of the big idea of making CS accessible to all in BPS and around. It's also going to talk about how why computer science and how computer science is integrated in everything. We'll talk about the AP courses. What are some of the ABCS course options? ABCS principles, which is called ABCSV, is launched this fall. So it's coming up in a lot of our schools are implementing it this fall. So we'll talk a lot about this course because it's brand new and it is really culturally relevant sort of curriculum that can be implemented for broadening participation in computer science. We'll talk about some curriculum, assessment, and resources aligned with both ABCS principles and ABCSA, which are the two courses. Then we'll talk about standards, a sort of path that teachers are advocating for in BPS. This is again a draft model, so it looks different for every school, but we'll talk about what sort of looks like in some of the schools in BPS. And we'll again look at some fun assignments, resources, and there is a small section of a smart world, which will be a fun section at the end of the session. Moving on. We'll look at CS from the lens of equality versus equity. So sort of defining these two terms is very important. Equality as defined is access for everyone and everyone gets the same thing. While as equity is everyone getting what they need when they need in order to succeed. And sort of that's the model that BPS is also looking at as they look for, making CS accessible to all in the BPS context. We are obviously looking at parameters in terms of encouragement, how to improve the perception of CS in the school, and then again, bringing it back home to making CS accessible to all. So instead of me talking about this, there is a really great media piece, a media asset that I'm going to show that talks about how equity in CS education is important. So give me a quick second. I'm going to switch my screen. Please do let us know if you cannot hear or see the video presentation so we can make amendments accordingly. So here we go.
This is a computer science classroom. Notice what this classroom looks like and who is in it. There are far more males than females, and there are few Black or Hispanic students. This is a typical tech company. We see the lack of diversity that starts in the classroom translates here to a lack of diversity in the modern workforce.
I didn't really have a computer class. No, my school doesn't offer computer science. Because I don't even have a computer at my house, and like all these other people are like, oh, this is so easy, and they just want to get it done and not really help other people, while I'm like yelling out to them like, hey, I don't know how this thing works, so it's more difficult. The teacher should give the kids more help on people that don't have computers at home than the people that do have computers at home. Nobody like encouraged me to do a program thing with apps and stuff like that. For girls, it's more like, oh, you're encouraged to do modeling or become a doctor.
Do I know anybody that works with computers? No, not really, no.
I have no idea who else that works with computer.
Well, I've told my mom about like the class, but like she really doesn't know that much because she really didn't go to college and like high school. She mostly only went to 6th grade and didn't go to school after that.
When you grow up, do you think you're going to work with technology in your career?
Not the field that I'm looking for.
I don't feel like I'm a technology person.
I felt like I wouldn't know anything, and I just felt like I would be left out because I felt like I was the only one that wouldn't know anything.
They just classify you, and I don't know, I don't like being the norm.
It's important to distinguish between equality and equity. Equality means everyone gets the same thing. Equity means each student gets what he or she needs to succeed.
There are a lot of factors that go into equity, more than just gender and race. When you have a group of students in front of you, you don't necessarily know who has what experience or who is combating what particular challenge in their life. You have no idea.
In my classroom, we do a lot of group work, and what I see in those groups is students are able to come up with solutions that are diverse, just like them.
I remind the kids that we are here to get an education, and I understand, life can get rough, but this is your safe space. This is your time to be a kid and, to learn and just have some fun.
If you have two people, one person who doesn't know as much as one person, and you give them both the same amount of learning, that's not really fair. You have to teach one person more than the other because they may not know as much, so they can reach the same level. So fairness is not always fair because sometimes people need more and sometimes people need less.
Sometimes the special needs student who you wouldn't even necessarily think it would be appropriate for him or her to be in your class, that's the student that has the most patience and the most perseverance and can really make a team stick together and say, come on guys, we have this, let's look at this again. That's the student that will enable all of the rest of them to be successful.
It actually would be better for women and men to be like working kind of like together on the computers, so they can get more done with power of two. It's about to get real.
Give me a quick second. I'm going to switch to a presentation. it is so important to have this conversation in our schools, in our classrooms, and sort of recognizing the opportunities that are missed when we don't reach all students where they are in order for them to succeed. Oops, I'm sorry. So why take an AP course? That's the common question that comes up when we talk about AP classes, and these are very standard reasons why people choose AP. It stands out in college admissions. It allows you access to different colleges in terms of your transcript. Over 2,600 colleges worldwide grant credit for AP scores. So, it's a recognized course offering all over the world. Students do get an experience that college recognizes. It also helps them acclimatize to colleges while they are in high school, so their transition is that much more smoother. They can skip introductory classes if they've taken an AP course. So it also helps in terms of how much you pay for those introductory classes, which really don't add up to your core requirements. It obviously helps you build college skills because APs are rigorous courses. So you sort of build up those study habits, study muscles in order to cope up with the requirements of this course. More than we can say about the AP course, that's why I brought in the video from the students from Bethel High School. So I want you to hear why they recommend AP courses. So give me a quick second. Going to switch.
Ready?
I've taken 3 AP classes last year, and I'm taking 3 this year.
This year I'm taking AP World and AP Language and Composition.
This is my first time taking an AP class.
This is my second AP class. I decided to take 4 AP classes because pushing myself has really developed me as a person and allowed me to excel in areas I didn't think I could excel in before.
I had 2 options for history, so I went AP just to see what it was like to do the harder classes.
I wanted to give myself the best opportunity to prepare myself for a college level.
A lot of people shy away from AP because they're worried about their GPA.
Usually college is looking for advanced classes.
Even if you get a B instead of an A,
It's gonna look just as good, if not better, than a 4.0 who took all regular classes.
I pay attention more because it's more engaging.
It's at a faster pace and it's more discussion, it's more analytical thinking.
We get more in depth into the schoolwork.
The teachers have been amazing.
I get to know the kids a little bit better, and we can tailor things to their interests. I just find that you learn more in an AP class than you do in a regular class. They get to work together, a lot more cooperative grouping, a lot more independent learning.
There's definitely more homework.
Be prepared to have a heavy workload.
You may be stressed out because of it, and it may be a lot of hard work, but it's worth it in the end.
You're not just trying to graduate, you're trying to better yourself, and you're trying to prepare yourself for bigger things in the future.
That's what my students have told me, that your classes really helped me be successful in college. Like, I feel a step ahead.
This is the actual rubric that is used on the AP exam.
If you do good on your AP test at the end of the year, then you get a certain amount of college credit.
That's fantastic because starting college and being able to get ahead of the rest of the class because you've already got these credits is a major advantage. Yeah, it's always nice to talk about getting college credit, but you're learning a skill set and a mentality of just how to be successful.
I would say take an AP class.
Step up to the challenge. Just talk to another student, talk to your teacher, talk to your counselor.
It looks good on a college application. They're really fun classes.
If you think that you're ready
Sorry. We are going to quickly switch because the video is going to have it's almost at the end of the video. So give me a quick second. So our focus is again not recommending a class for you, but it's sort of advocating for some of the opportunities that students get through AP. It's as the teacher said, it's a skill set, sort of building up that the study habits and the skill set required for these courses. You don't have to have the AP course numbers or the scores in order to get the college credit, but just going through that experience really allows students to have a more grounded learning experience. So again, we came back to this, and I'm going to use a lot of the media presentations in this because that was highly recommended by a lot of teachers who integrate media into their curriculums, and that has empowered them to get that voice that much further for students, because students live in a very media-friendly world. So why computer science? I think computer science, as we all know, is everywhere. It's in all our applications. It's in all offices. It's in all fields, let it be music, medicine, or much, much more. Computer science also helps you understand how computing and technology influence the world, and it also allows you to creatively address real world issues. So students can be part of the processes. They can be artists, they can be writers, they can be engineers, but it allows them to be part of that whole computing and technology influence that they can they can participate in and further. Here is a really great information about how computer science is in all the fields and how it is really impacting change in most of the fields. So let's quickly take a look at the AV. Okay.
I think 19th century was about the Industrial Revolution, about electricity, about disrupting the agricultural society and making it more advanced. The 20th century was about physics and engineering to do more things easier in our everyday life, from refrigerators to washing machines. And the 21st century is definitely the digital age. It's the internet.
Even if you want to become a race car driver or play baseball, or build a house, all of these things have been turned upside down by software.
The lettuce bot is a robot that can sense its environment. Every single hour, this lettuce bot is seeing 1.5 million plants, and it's taking individual action on those plants. We enable lettuce growers to have higher yields in their field by helping make it cheaper, by helping produce food in a more sustainable way. And that wasn't previously possible without computer science and technology.
I have a really fun job where we build Polyvore, which kind of combines all my favorite things, so programming as well as fashion and art and design and shopping. Half the products you use these days are software products that you play with on maybe your phone. And so if you want to build something cool, you need to know programming, right? And there's so many things that you can do with computer science. So if you just work backwards from the cool thing that you want to build and figure out what that is, a lot of times computer programming is part of that, right? So you should learn the skill. It's really exciting right now. The technology that we're developing right now is going to be used by your doctor in the next decade. When you come into the office and you're sick, the doctor is going to be like, all right, spit in this cup. And I will put it into this magic machine, which is the sequencer. And in an hour, I can tell you what you have or what's wrong with you. So if we're looking for a new virus, for example, we'll download a database of all the viruses that are known. And we'll search for, our sequence of interest against a whole database of all viruses. So you still need somebody to analyze the data. The computer is not smart enough yet.
Our software helps people save energy and thereby reduce their carbon emissions. To date, we've saved over 8 terawatt hours, which is the equivalent of about 1.1 million cars on the road.
When you're forecasting the wind, there's so many different parameters that go into it. It would be impossible for a human to sit down and do all those calculations. We need a computer model in order to forecast it.
Most people don't think about technology and public safety as going together, but our software is actually changing the way that law enforcement is capturing, transferring, and managing their digital evidence on a daily basis. Turns out that when officers are wearing our cameras, they see a drastic reduction in use of force, as well as a drastic reduction in the amount of complaints being leveraged against their agency, ultimately resulting in safer communities.
The merging of art and technology is getting more and more significant now because computers and software are such an integral part of our lives day to day. People are realizing that it can be quite creative to take this medium of computers and create incredible works of art.
In Finding Nemo, when Crush and Squirt and all the friends are flying through the East Australian Current, you're seeing images of water flowing by, you're seeing the colors on the back of the turtle, you're seeing the sides of the fish. All of those things are generated through math and computer programs that we write that we then give to the artists, and they take that to create that final image and tweak it and make it look beautiful and look fun.
The crux of it is really about invention. It's about looking at the world and being dissatisfied with things and questioning everything.
I always felt like if I didn't learn how to program, it would be like not learning how to read. You know, the future would just be closed to me.
If you're in the coding profession, there's so many things that you can do, and you can pretty much pick and choose the course you want to be in.
I think that you can start something in your college dorm room, and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
Really, it's about the chance to reinvent things and then see it out there in the world and see people using it and having fun or having a better life because of something that wasn't there before that you put in the world.
You're going to move back. Oh. Okay. So coming back to our discussion about AP Computer Science courses. So this, give me a quick second. Present to everyone. Yes. So this sort of this graphic gives you a very quick overview of the two courses that are offered in the AP Computer Science space. So you have the AP Computer Science A, which is the traditional course, which focuses on the fundamentals of programming and problem solving, and it uses a very specific language, which is Java programming. So you learn a whole lot about this object-oriented programming language, which is Java in this case. Computer Science Principles, which is a course that comes before Computer Science A, is essentially developed. It focuses on the fundamentals of computing, including problem solving, working with data, understanding internet, cybersecurity, and sort of general concepts of programming. The goals are very different for both the courses. With ABCSV, which is AP Computer Science Principles, it is a fundamental course. So it is looking to broaden participation on your understanding of computer science, and it also has a lot of curriculum that comes from diverse backgrounds. Like you have things from creativity, so arts and entertainment. You have certain programming expeditions, and it's a very sort of flexible syllabus, so you can modify it significantly. The goal for ABCSA is again, getting to the nitty-gritties of that computer programming language and the syntaxes, and sort of understanding how that fits into the big picture. And then you have programming tasks, you have programming assignments, which are very much focused on Java. And again, the exams, the outcomes of these exams are also very different as defined by College Board. So for AP CSA, you have one year-end exam, which has multiple choice and free response questions, while as AP Computer Science Principles gives you 2 projects during the course of the year, which forms a part of your AP digital portfolio, and we'll talk about it in a little bit. But that sort of gives you 2 projects to work with creatively throughout the year. And then there is one end of the year exam, which is a multiple choice exam. So these are simple differences between the 2 courses and the offerings around these courses. So let's sort of go into the main questions. Will students sign up for ABCS Principles? Because that's the introductory course that's being launched in fall and is sort of aimed towards broadening participation of CS. So look at, there are a lot of students who talk about, why they should be taking ABCSP, or why they should be looking at ABCSP. So I'm going to show you a quick student example of how music is integrated into ABCSP, or how the student talks about it. So give me a quick second.
It's just amazing, like, what music can do. Just to make a great song with, like, instrumentals just fluently coming up with another section, a bridge. Like, just the creativity and just showing your flavor, just showing, like, everything through code is just amazing. I felt like I was in the studio just making a hit for everyone. This is what I've been waiting for like forever. Finally, like, it was like my favorite part of the curriculum.
Well, me and my family really like to travel. I always pack everything because I don't know what to bring. For our app, we found data that displayed averages for the temperatures in certain locations. So you can choose the month, and then based on that, you could be presented with recommended apparel and the temperature. It was really rewarding, like having something physical to look at and say, okay, I made all this, like I know what it does, and I made the program into it.
So as we look at ABCS Principles, it is this creative aspect of ABCS Principle that allows you to integrate different modalities of curriculum into the course. So both these student examples actually come from the ABCS Principles pilot courses that are happening, or that actually happened last year. And we'll look at the syllabus from both these teachers. And you can see that, how they have integrated some of these components in it. And you'll have, of course, in your resources, you'll have access to these syllabi as well. So let's quickly take a look at what essentially, what are the logistics or the nitty-gritties of the AP Computer Science Principles. So AP Computer Science Principle is supported by National Science Foundation and is agreed to be a course that was needed to increase the number of students interested and prepared for success in computer science, and of course other STEM fields. So that was sort of the overarching goal of ABCS. Again, so what are the differences between, bare bones differences between ABCSP and ABCSA? The AP Computer Science A course and the exam focuses on computing skills related to programming in Java. The new AP Computer Science Principles course will complement AP Computer Science A and will focus on the fundamentals of computing, including problem solving, large scale data, sort of concepts about cybersecurity, internet, and creativity elements woven in. When we look at exam administrations, the AP Computer Science Principles exam will be administered, and it'll start taking place from May 2017. Dates might vary, but the details will be updated on the AP College Board, but May 2017 is when they will be launching the exam for AP Computer Science Principles. So what does the assessment kind of looks like for ABCS Principles? The assessment consists of two parts: a thorough course assessment and end of year AP exams. As I said, there are these two projects that the students will be doing depending on the syllabus for the course. And basically both of these assessments, the portfolio aspect of it, which is the projects, and the end of the year exam, both of these assessments focus on the course learning objectives. So it's very much tied into the framework for AP Computer Principles, the learning objectives for AP CSP, and how they are implemented in a syllabus. For a thorough course assessment, students have to upload these digital artifacts and written responses via sort of a web-based portal, and that will be made accessible to the teacher who is teaching the ABCSP course. So why do ABCSP at your school? Again, you have to be looking at how your school is going to adapt CSP principles. Right now, as we look at some of the schools who will be teaching principles in fall, they've done Exploring Computer Science or an introductory computer science course before launching into AP Computer Science principles. So that's sort of, they have an introductory course before they go into this College Board defined introductory course for principals. So that could be a potential path if you want to look at offering ABCS principles at your school. In terms of teacher experience, we'll talk a little bit more about that, but sort of there are state-specific computer science teacher certification requirements. There is a lot of discussion around that happening, so we will of course update you with that. But there are these MADLCS standards that are coming in. There are CSTA ACM standards, which we are going to refer to later on in the presentation. They both are working together in order to bring about the CS certification for teachers. But right now, there is no certification for AP Computer Science principles other than going through the AP College Board approved professional development, which sort of gives you the tools necessary to implement ABCSP in your classroom. This was a very critical question in terms of, do educators need to know a specific language for ABCSP? We'll look at the syllabus for ABCSP, which is a generic model, and there are close to 12 languages that they have recommended that you can implement. They range from block-based programming to text-based programming, and so ABCSP gives you that flexibility, you as a teacher, that flexibility to integrate a different language into your syllabus. Of course, if you want it to be College Board certified, there is an audit process that you have to go through for your specific syllabus. But you can always adapt an existing College Board approved syllabus, and then you are all set to go with that specific curriculum, because the curriculum does offer you multiple language options in these 4 different syllabus. What's the prerequisites? Well, it's not required as per AP College Board, but they very strongly recommend Algebra 1 before taking AP Computer Science principles. And we highly recommend taking an introductory course of computer science before going into AP Computer Science principles. So here is a quick, Code.org has done a really great job at talking about AP Computer Science principles. So I'm going to quickly go to Code.org and to give them an opportunity to tell you.
It's pretty amazing when you start building something that you want, it can help change a lot of people's lives as well. And having even a little bit of grounding in computer science can help you think about the world differently, whether that's algorithms or whether that's just creativity.
Computer Science Principles covers lots of topics, not just programming and coding. We cover bits and binary, we cover how the internet works, how security works, how data is collected and used and shared. And all of these things help you get a better understanding of how the world works. Now I understand why my phone is so slow.
I thought computer science was just for really, really smart, nerds, geeks, but it's not at all. It's for everybody, and I think it's something that everybody should learn.
In the new economy, computer science isn't an optional skill. It's a basic skill.
I just think it's important moving forward in the future that everybody learn it, especially kids.
I didn't know what I was getting myself into. But once I had my friends around, I knew if they could do it, I can do it. So it's really like brought my confidence up in other classes as well.
If you use Snapchat and Instagram and you want to know how that works, take computer science principles. Make an app yourself. See how you can share these things with your friends.
Be able to code gives you the freedom to build anything. And that is just so empowering. We're doing like a lot of teamwork, like group work, like doing work on paper, not just always on the computer.
And then when I say go, we're going to exchange IP addresses without talking. And I want everybody's IP address.
Some of the kids that maybe don't fit in the normal classroom, they have an opportunity to kind of try different things and different techniques and different mindsets.
It feels more like a puzzle, and you get to take your own route and find a solution.
I feel like this class is like one of the only classes that challenges me. That I feel like, you know what, I got this. Like this is good.
Computer science isn't just about math or computers. If you're interested in designing things, creating things, solving problems, then this class is for you.
Yeah, so that was code.org telling you a little bit about their version of computer science principles. And they do a really good job of sort of weaving in all the components that are included in the computer science principles course. So let's look at, again, some more logistics. What is the recommended classroom setup for computer science principles? It's, it goes from 2:1 to obviously, a group of 4:1. And depending on, your infrastructure, you could do a whole class instruction with Chromebooks as well. So again, the syllabus is key. How you define your principal course is going to define what kind of classroom setup you need. I'm going to talk about resources for ABCSV in just a while, so I'm going to sort of wait on this so that you can see the whole slew of resources available to you. A lot of people have asked me this question before as well, which is about ABCSV credit. Now, over 120 colleges and universities were, participated in this survey, and 88% of these participating institutions believed and agreed essentially to give AP Computer Science Principles a college level computing course recommendation. So that also means 86% of them indicated they would award college credit for the course. There is a whole logistics about which colleges are going to offer credit for ABCSV principles, and that will be hosted on AP College Board website. So even as you're teaching this course, going to that page and sort of looking through institutions to see which are going to offer credit as you do this course would be a really great discussion with the students, especially as they're looking to apply to some of these schools. There is a submission timeline when you submit your own ABCSV syllabus, and we'll talk about that when we talk about the auditing of the course aspect. Again, professional development opportunities also sort of comes into the resources section, which is when we are going to address that. But what training is necessary for educators? College Board has very specific, they have partnered with endorsed professional development partners, because part of it is, being able to teach the curriculum with learning objectives, with standards in mind, and the activity should align very well with those. That's why College Board has these endorsed. This is the very first time actually that College Board has approved a lot of these external professional development providers, and sort of looking at them and looking at the options that they offer is a great way to start in terms of, a more in-depth professional development. Like code.org is part of the program as well. And so, looking at those would be a really great way of starting the professional development journey for ABCSV. We'll take a look at it in our PD's resources section so that you know who are the providers and what they are offering. And then sort of, if you look at the performance tasks, you'll get an idea of the 2 performance tasks that they offer. We have an assignment in here where we have given you the handout that specifies the performance tasks underlined for ABCS principles, just so that you have an overall idea of what those look like and what is required, how much time is required to sort of plan in terms of the performance tasks. Can students take ABCSP without taking AP exam? Yes, of course. It is a really great course to get students into computer science, and they do not have to take the AP exam if they do not want to, but it is a really enriching experience for them in terms of learning the concepts, implementing them, and having these performance tasks. So they're doing projects from scratch. So it allows them to have that experience of computer science, a hands-on experience of computer science. Moving on, I did mention a little bit about the performance task, and we'll look at them together. But when you're planning, look at, College Board says 20 hours, but a lot of the teachers recommend close to 40 to 60 hours for these performance tasks. So because sometimes students come at different levels in terms of their skill set, so sort of building that in. We talked a little bit about the recommended course sequence for BPS. We highly recommend taking an introductory CS course, like an Exploring Computer Science or Intro to CS, before you go into AP Computer Science Principles, and then AP Computer Science A, which is the Java programming College Board offering, you can take after AP Computer Science Principles. Software, hardware requirements, a lot of them sort of aligns again with the syllabus that you're teaching. Some syllabus do allow you to work with Chromebooks and computers that are using web-based applications, so that will suffice. But a lot of them, so if you're using, for example, JavaScript or specific programs or robotics models into your curriculum, then if the program requires a software that needs a computer, say a Mac or PC, then that would be a requirement. But on an average, I think the syllabus will decide what specific software or hardware requirements you will have. We'll talk about the AP digital portfolio in a bit, or sort of in a more elaborate way, but I just wanted to refer to it. It's sort of a it's going to be a web-based software application that will facilitate the process of collecting and transmitting the ABCS principles course, sort of, they call them performance task evaluations. So this will be a standard sort of digital portfolio that will also go to the AP reading for scoring. So that's going to be a standard web portal that every teacher teaching AP Computer Science will be using if they want the students to appear for the AP CSP exam and to get credit for the performance tasks. And then, that will be launched. The AP Digital Portfolio Access will be launched for you if you join one of the College Board approved PD, sort of, I call them access points or PD offerings. And again, sort of, you can also form your own performance task for students, especially if your students are not appearing for the AP Computer Science exam, Computer Science Principles exam, and that could be housed in a Google Drive, or you can have like a Google site where you host these portfolios, and that can be an ongoing discussions with your computer science class. So there are various modalities in which you can implement this digital portfolio model. This is a quick information, sort of teachers, students sharing their input about how, and all the teachers featured in this video are the teachers who have developed the AP Computer Science course. So AP Computer Science Principles course. And so sort of they come from a place where they have worked with the students and they've worked with the syllabi and the project. So it's a really great resource. To give me a quick second to listen to them. Okay.
I see computer science everywhere. Smart medicine that can monitor your body. National security issues. Sonar technology to view the inside of your body. It's saving lives. It's helping people. Computers have transformed everything we do. Computer Science Principles is a broad introduction to computer science. It's not about syntax, it's about creativity. They can read and understand how the internet functions. By the time the course is over, they'll have several apps that wouldn't exist if it wasn't for their learning.
I ask my students to look at the world and to think about things that are in their world in terms of data.
They can actually understand how instructions are given to the computer. We went from talking about how the internet travels and how computers started to where the first computer bug came from, an actual bug. I have people from the basketball team, football team, people in interior design, theater, tech people. Somebody takes my class, they're in the band, they want to learn about music, I'll teach it to them on a program that has to do with music.
I felt like I was in the studio just making a hit for everyone. This is what I've been waiting for forever. Just showing your flavor, just showing everything through code is just amazing.
Being able to press, enter or run and see my world pop up.
It's just like painting or drawing.
My cursor is your paintbrush.
A lot of girls are intimidated because they see computers as like a guy thing. If more girls were like encouraged, then that wouldn't be an issue anymore.
You don't even think you're creative. And then you have a course that makes you see yourself as creative.
It kind of feels like a new light has turned on.
Computer science, I feel like, has really helped me with my confidence.
The biggest change I see in students is their confidence. This class teaches kids how to think.
And I'm going to allow you to look at the rest of the video. Obviously, we'll put in the link into the BPS Learns. Let me quickly go back to our presentation. Yeah. They are a really great group of teachers who have provided a lot of resources to us. So let's look at, ABCSV course exam description. So these are the nitty-gritties of it. So let's look at, this is how, this beautiful purple course and exam description is that of AB Computer Science Principles. And what does it have? It includes, there are these 7 big ideas that focus on creativity, abstraction, data and information, algorithms, programming, the internet, and the global impact. So these are the 7 big overarching ideas that the ABCSV is designed around. There are also 6 computational practices in this course and exam description. So let's quickly take a look at, there is a lot of information in here, and we'll definitely attach a link to this into the BPS Learns. I believe I have already, but if not, I will update it. But these are the computational thinking practices which are critical to the CSP Principles curriculum. So it's connecting computing, creating computational artifacts, abstractions, analyzing problems and artifacts, communicating, collaborating. These are, sort of the main principles. And then you look at the big idea. Every big idea comes with essential questions and learning objectives and essential knowledge. So when you're designing your syllabus or you're looking at any syllabus that's been approved, these are the connections that that AP College Board is looking for, especially as you look through implementing this in your classroom. So there are a lot of examples in here that sort of state how an example can be written for a syllabus. I wanted to take you to the place where they actually talk about so one of the performance tasks. Let's look at the, I wanted to take you to where they have the listing of these 12 languages that you can use. But maybe better yet, we can, let me go here. And again, the curriculum framework around this ABCSP course is focused on defining what students need to do and understand. Computational thinking practices are the core of this curriculum, and establishing assessment targets and boundaries, wherein the digital portfolio and the exams come in. ABCSP resources. We are going to quickly go to the ABCSP resources page. This is the resources page, and it has information about the course homepage, the endorsed providers that we are going to look at, especially when we look at the professional development and curricula support. There is a toolkit, the course and exam resources. I love going to this course planning and pacing guide. So let me see if I've already opened it. Yes. So in the course planning and pacing guide, right here, you can see that there are these 4 teachers who have developed the curriculum. And if you see the differences between each curriculum in a short way is they all use, they have a different setting. So for example, Art Lopez taught in a diverse urban high school. He used Alice programming as a platform to create simulations, and he has manipulating 3D objects as part of his performance tasks. Chimauche is a teacher who is teaching at the public magnet school. She focuses a lot on mobile CSP, Android platform, and has a bunch of projects built into her syllabus. If you click on any of these links, you can see the syllabus right there. And let me see, Richard Kirk teaches it using JavaScript. That's his language of preference, but he also has them building websites, and again, they address all the big ideas and the computational thinking within their curriculum. And Andrew Kumel, he teaches it using Scratch. That's his main programming platform. And he has a lot more sort of performance tasks which are focused on Scratch. So one of his performance tasks that we are going to look at, it's not his final 2, but one that builds up towards his performance task is sort of building the rock, paper, scissors game. And if any of you have watched the Introduction to Scratch webinar, we attempted to design one which had certain parameters. So we'll take a look at that project to see how it varies for ABCSP principles. So quickly going back to, we looked at all of these opportunities. These are a source of materials that you can, when you have time, you can look through a lot of these materials, because it is a lot. It is a lot of resources available on AP Central, but sort of taking your time and looking at it and sort of digesting it from the perspective of the syllabus that you want to teach is the best way to approach it, is the advice of the educators who've done this during the pilot course. We're going to take a quick look at sort of the AP Computer Science Principles course homepage. And as you can see, you can submit the AP CSP audit materials before. So the start of the audit process and before September 1st, 2016 is the time when you can submit. If you have a syllabus that you have designed, you could submit it before that date. Moving on. As I said, this is what I've done is I've taken a snapshot of one of the programming assignments from the last syllabus, and it talks about specifics of an example of you have to develop the algorithm. You have to look at the learning objectives. The learning objectives say develop an algorithm for implementation of a program. So in this case, the challenge is developing a program for rock, paper, scissors, for that game. And so they have to write that algorithm out. It could be a flow chart, or it could be how they are thinking about it. They have to express an algorithm in a language. So they literally have a journal entry about how they came up with the algorithm, how they, why do they want the components that they want in this game. So sort of reasoning it out and then building that algorithm. They develop a correct program to solve problems. And, that is still, they're not yet building it, they're testing out. So they test out smaller modules to see if they're working, and successful, simpler models come together to build up the program. But I think the fourth and the learning objective is really cool, because it says how explain how correct programs or how programs implement algorithms. So in this case, they advocate for looking at different programs done by, so if you have a class of 20 students, they will be looking at the rock, paper, scissors program developed by, say, 10 of the students in groups, and they look at each other's code or even codes outside to see how it differs from each other. So sort of going back to, I'm going to quickly share my Scratch space, and I just went on to the Scratch website, and I typed in rock, paper, scissors. And if you do a search, you will find close to 100 examples of rock, paper, scissors. And these are all programs that you could take a look at, see in terms of how they have been implemented. But the recommendation is, and this is part of the assignment too, that you look at maybe 2 programs. So for example, let's look at this program. And in this program, when you click on See Inside, it gives you, okay, let it load. Okay, so it gives you, when I look inside, it gives you how it was structured. And in this case, the conditional statements used are if else. So sort of understanding this program, and then this is a more robust program that I looked at, but what teachers give is a weighted implementation of 3 or 4 rock, paper, scissors game, and then students compare and contrast amongst these codes. Scratch is a great tool because it allows you to sort of remix, look at the code, and actually analyze some of these codes. So when we talk about assignments, we're going to give you a quick perspective on what we want you to play with in terms of analyzing an algorithm. Let's look at, in this program, I also wanted to quickly point out that if you see in the right-hand corner bottom, there is a tree diagram. It says 20, which should show you that this program, whoever wrote this program, 20 of the users have sort of worked on this program and have modified it or remixed it. And to know more about some of the terms that we are using, we highly recommend you watch the Intro to Scratch webinar, which happened last week, if you haven't already. And we'll also list a lot of resources about basics of Scratch in the resource section of BPS Learns for this webinar, so that you can sort of grapple with this. But this is one of the introducing objectives of the programming unit. So you kind of want to look at it and see how you see programs differently, especially if you're looking at 2 rock, paper, scissors examples. Coming back to again, the last learning objective is evaluate the correctness of a program, which is very interesting because you run it and then you have errors and then you correct it and you go back, and those are some of the ways in which you can evaluate it. ABCSP student site has, so this is the ABCSP student site. There is an English version and then there is a Spanish version, which was really great. This was highly recommended, so they actually went ahead and launched this. So you can see there are a lot of resources for students, and this diagram that we looked at in terms of how these two are different is right from here. So it's a really great source. On the right-hand side, you can see, there is an enrollment checklist for parents and guardians, and a lot of these clubs that allow you to get involved and learn about computing. So there is, this is a really great way of looking at the colleges and exploring your future. So this is where you would go in to see if what colleges are going to give credit and information about that. The AP course audit, we talked about it a little bit, but this is, if you develop your syllabus, you have to submit it to AP College Board by September 1st of 2016 for approval, and that's the timeline for submission. What they have in here are these 4 sample syllabi that we looked at. I highly recommend you look at them anyways. We have this as a part of your Go Beyond activity, but sort of realizing how they vary and what are some of the examples or projects that they are looking at. Moving on. Yeah, we're going a little bit over time, but please bear with me because this is some important information that we're hoping that you can share with your colleagues or with your students. So this is what you're seeing right now is an example of the BPS HS pathway, which is sort of comes out from some of the teacher discussions that we've had. And AP Computer Science comes under, after the Introduction to Computer Science Principles, which is what we are recommending. On the right, you see that there is a quick lesson plan. What I've done is I've cut down the lesson objectives and details, but kept the CS principal learning objectives and the computational thinking CT and computational practice and programming, which are called CPP objectives. These are part of the CSTA K-12 computer science standards. Now, CSTA K-12 computer science standards came into being at around 2008. There are 5 principal components to it. Computational thinking, these are the strands, and our MADLCS standards are also sort of inspired. I like to use the word inspired. They're inspired by the CSTA K-12 standards. The CSP Principles course is aligned very well with the CSTA K-12 standards, which are nationally recognized. And again, there are 5 strands in this, and if you look at the MADLCS standards, there are 4 strands. So you can see how these standards merge and how these courses obviously very well align with the upcoming MADLCS standards as we go into implementation stages. I'm not going to go too much into AP Computer Science A just because, it is a course that it has been around in the courses, but you have to sort of go through 2 pathway courses before you get to Computer Science A. This is the this is a quick course overview of AP Computer Science A. Topic outlines, as you can see, it is very highly focused on object-oriented program design, specifics of programming. It's a very wonderful course in terms of learning an object-oriented language, regardless of whether it's, Java may not be implemented 10 years from now, but the concepts really stay with you. So it's a great course. There is a lab requirement, and the exam structure is, multiple choice 40 questions and free response 40 questions. This is a link. We have posted a link to the entire course description for AP Computer Science in the resource section. This is great reading if you have some time, but again, our recommendation is go through the course sequence of introductory course, CS principles, before you think about AP Computer Science A. And this again is the AP Computer Science student portal, where you can go in and students can engage in different activities, or sort of how to enroll, how to understand a Java subset, or what are the lab requirements. But again, focus on the sequence that is highly recommended for sort of by the teachers within BPS, because they've been working with it for some time. Session 2 assignments. Please note, sort of all links are posted on BPS Learns, but the exit ticket is there. Respond. Sorry, I apologize. Haruna just pointed out it's session 4, and it is. I apologize. I have a typo. I'm sorry. So session 4 assignments. Definitely respond to the session 4 homework, which is right here. The first exit ticket is great. Do email us if you have questions. There are readings and journal entry, and we have posted the links. The third assignment is tricky. So we highly recommend you please watch the Intro to Scratch webinar, or we are going to post some introductory Scratch webisodes, which are, like 4-minute tutorials, a link to those, and take a look at it. If you have trouble with the third assignment, please email us. It is not to make your job difficult. It's just sort of you looking at what is a primary objective in a say Unit 3 and sort of what students are looking at. So if you have any questions or problems, or you want more resources, please email us, and we can also work around how to assist you at your specific with your specific questions. There is going to be a go beyond optional. It's a research assignment, but again, it's an optional assignment, which will be posted on BPS Learns. Recommendations. I have a habit of looking at a lot of articles that come out for CS or CS related, and this was a really great suggestion from one of my teacher friends. And then they talk about how to figure out why you want to learn to code, but how to learn coding or teach yourself coding, especially as you are traveling through the CS landscape. So their first recommendation is figure out why you want to learn to code, and sort of looking at this whole spectrum of, what is the motivation behind coding. They also talk about, if you're starting, choose a right language. There are many different languages. And in the introduction, we've talked about, you have these pre-programming skills, you have block-based languages, text-based languages, but they have some really great recommendations as to how you can start. Start small. Of course, you have to be patient. There are books out there which say learn coding in 8 days and learn coding in 20 days. It's sort of taking it. There is David Sinsky, who has talked about learning coding in 8 weeks, and he has a very algorithmic process to learning coding. So it's a great read if you have some time. Definitely try kid apps, and when we say that, it's work with Scratch, work with some applications, and sort of learn basics of or fundamentals of programming. Scratch is based on C, which is a procedural language, which is quite a bit different from an object-oriented language, but it gives you the fundamentals of programming in terms of how you should be approaching an algorithm design. There are free training sites. People recommend that. Take a coding course if you feel like. MIT has an open courseware online that allows you to take this amazing Introduction to Computer Science course. It has close to, I believe, 600,000 views, and people just watch it because it's a great MIT professor, head of the department, talking about computer science and introducing it as their course 600, which is their introductory CS course. And last, sort of be a mentor or get a mentor. There is a Hack Pledge. That's a really great site that will connect you to a mentor or you can sign up to be a mentor. I especially like this last one, which is, hack someone else's code. It's not in the negative sense of the things, but especially when you reverse engineer someone else's code, it gives you the step-by-step understanding of what one person has put into it. And I believe that is one of the reasons why ABCS Principles has that as one of the objectives, because they want you to look at different modalities of codes and understand it and play with it and compare, contrast it. So it's sort of a very age-old reverse engineering trick to learning coding as well. That brings us to resources. We have posted a lot of these resources. There is a code concept video. I wanted to show you that, but we are sort of 8 minutes over the time. So I don't want to take more of your time, but I'm going to attach that link. It talks about packets, but code.org has really amazing concept videos that they have put forth, especially for their ABCS Principles course, but you can use it in your class as well. Code Academy, Khan Academy, there are CS Unplugged activities. This is the professor, I was talking about it, and I was so wrong. It's not 600,000, it's I believe it's 3,092,000 views. So that's something. So it's just, and this is a purely introductory computer science course. He does not have any other content in there. So it's a great course you can take for free. There is Dash, there is Grok Learning, things that will help you learn about coding. And last but not the least, I just had to end with this. it's a quick, fun video about, give me a quick second, about internet. And Smart World is a series that my daughter is going through at her school, where they learn about these concepts from different, about the world in different ways. Right now they're learning about planets. So I decided to borrow that, and here is a nugget of our Smart World.
What is the internet?
The internet is like a popular thing.
Some satellites up there.
I'm picturing my head with like waves of internet going to the phone. Somebody told me a cloud once.
The internet is a lot like plumbing. It's always moving.
Most people don't have any idea where the internet came from, and it doesn't matter. They don't need to. It's sort of like asking who invented the ballpoint pen, or the flush toilet, or the zipper. These are all things we just use every day, and we don't even think about the fact that one day somebody invented them. So the internet is just like that. Many, many years ago, in the early 1970s, my partner Bob Kahn and I began working on the design of what we now call the internet. It was a result of another experiment called the ARPANET, which stood for Advanced Research Projects Agency Network. It was a Defense Department research project. Paul Barron was trying to figure out how to build a communication system that might actually survive a nuclear attack. So he had this idea of breaking messages up into blocks and sending them as fast as possible in every possible direction through the mesh network. So we built what eventually became a nationwide experimental packet network, and it worked. Is anybody in charge of the internet?
The government controls it.
Elves, obviously elves. The people who control the Wi-Fi, because then no Wi-Fi, no internet. T-Mobile, Xfinity. Bill Gates. Bill Gates. Right?
The honest answer is, well, nobody. And maybe another answer is everybody. The real answer is that the internet is made up of an incredibly large number of independently operated networks. What's interesting about the system is that it's fully distributed. There's no central control that's deciding how packets are routed or where pieces of network are built, or even who interconnects with whom. These are all business decisions that are made independently by the operators. They are all motivated to assure that there is end-to-end connectivity of every part of the network, because the utility of the net is that any device can communicate with any other device, just like you want to be able to make phone calls to any other telephone in the world. There's nothing like this that has ever been built before. The idea that what you know might be useful to somebody else, or vice versa, is a very powerful motivator for sharing information. By the way, that's how science gets done. People share information. So this is an opportunity for people to think up new applications, maybe program them as apps on a mobile phone, maybe become part of the continued growth of the infrastructure of the network to bring it to people who don't have access to it yet, or just make use of it on a day-to-day basis. You can't escape from contact with the internet, so why not get to know it and use it?
So that's the creator of internet talking to us. He has a whole series about internet data routing packets and everything. So please feel free to look at this. It's a Smart World, Happy Computing. This is Rashmi.
And Haruna.
Bye-bye. Thank you.